On today's flip video tutorial, we are going to talk about how to look at polar equations in terms of graphs. So basically how to look at a polar representation in a graphical manner. So what do you mean by that? Now we know that if you have a rectangular equation, then there are many ways that you can use to graph that rectangular equation. Like if you have y equals x squared, you know that it is a parabola. But if we have a polar equation, like say r equals 2 cosine theta, how do you know what the graph would look like? That is our main problem. So let's look at some very simple examples. Okay. Now let's try to understand what this graph will look like. Now r equals 2. Now r is the r of the polar representation, and that r is set equal to 2. Now how would you look at the graphical representation of this equation? In other words, how do you draw the graph of this equation? This is an equation but in polar form. So what I would do is to start thinking. Now there is r in this equation, but do you see any theta in this equation? There is no theta in this equation. What does that mean? This equation is independent of theta, which means theta can actually take any value. So what do you really mean? What does that really mean? So if you think about it in a graphical way, if you think of it that in a graphical way, let's try to draw the graph here. So theta can be anything. That means theta can actually, r is fixed at 2. So what is r? R is the distance from the origin to the point. So the distance between the origin and the point is fixed at 2. But theta can be really anything. So what is happening here? R remains at 2, but theta will just vary. So do you see a kind of a circle taking place? Well, it's not a really good circle, but you get the idea, right? R is fixed at 2, right? So this is really equal to 2. But theta can be anything, because the equation has no theta in it. No theta. So this equation actually represents a circle of radius 2. Right, so that's our first example. Now let's, here is a better graph of the equation than what I drew. Now let's look at a second equation. Theta is equal to pi over 6. Now in this one, there is theta, which is fixed at pi over 6. So theta cannot change. Theta is fixed as pi over 6. So in other words, the angle is fixed at pi over 6. Right, okay. What about r? This equation is independent of r, which means r can take anything. So that means the angle is fixed, but the distance from the origin. So if I draw the thing once again, this angle is fixed at what? Pi over 6. But the distance from the origin can be anything. It can be like this, or this one can be origin can be like that, or this one can be origin be like that, or this can be origin like that, or you can even take a point further up where the distance is this, or down here. So you can see that the distance can vary without a problem. It kind of looks messy, but you get the idea, right? So really look at it. What you have is the angle is fixed as pi over 6, but the distance can take anything. So what do you really get? You get a straight line with a slope having an angle pi over 6. So that straight line is shown here below. Alright, so once again, the way to look at this would be, this is independent of r, so the distance from the origin can take any value. Okay, now let's look at a third example. Now let's look at this example where we are asked to plot r equals to sine theta. Now for an example like this, it is not immediately clear what this equation is because there is r and theta both. So we apply two methods. One would be to just plot in some points and see, but that we will do when there is no other option available. So a better method to use at this point would be to convert this polar equation into rectangular coordinates. Right. Now when you want to make the conversion, remember that r is equal to x squared plus y squared radical, and x is equal to r cosine theta, and y is equal to r sine theta. These things will help you to convert this into x and y. You need this in x and y. Alright. So how do you convert this into x and y? That's the next question. Okay, how do you convert this into x and y? Now r is equal to square root x squared plus y squared. So one way out would be to put square root x squared plus y squared right up here. But that's kind of messy because we don't really want to put a radical in an equation unless we can avoid it. So how do you avoid this radical? One way to avoid the radical would be to square both sides. Now when you square both sides, this side you get r squared, and when you square the right hand side you get x squared plus y squared. So if you square this, right, but rather than squaring it, another way to get the square would be to multiply both sides by r. If you multiply both sides by r, then this side becomes r squared, and that is exactly what you want, which is x squared plus y squared. So we multiply both sides by r, and then this side will become r squared, and the right hand side will become 2r cosine theta. But we know what r is. R squared is equal to x squared plus y squared. So we can go up here and plug in x squared plus y squared up here. And on the right hand side, if you look at this piece right here, not the 2 but the piece other than 2, that is r cosine theta, which is just x. So we have this to be equal to x squared plus y squared, and this is equal to 2 times r cosine theta is x. So we have x squared plus y squared is equal to 2x, because r cosine theta is equal to x. So what do we have? We have an equation x squared plus y squared is equal to 2 times x. Okay, x squared plus y squared. This is 2 r cosine theta is equal to x from this one. So x squared plus y squared is equal to 2x. Now this is actually a circle. Now how did I know that this is a circle? If there's an equation where you have an x squared and y squared, and if the coefficients of x squared and y squared are the same. Now in this one we have the coefficient of x squared is 1 and the coefficient of y squared is 1, and there are no xy product terms, right? I mean, this is not a product term, this is 2x. Then that's a good indication that what we are dealing with is a circle. But in order to make this look like a circle, you gotta do a little bit of massaging. So what you do is you bring the 2x over to this side and then make it look like x squared plus y squared minus 2x is equal to 0. Now what you do is you complete the square on both x and y. Now here the y squared is by itself, so there's really nothing to complete the square there, but you can complete the square on x. So let's put the x squared and the x terms together, then you get x squared minus 2x and the y squared. But if you want to complete the square on x, then what you do is you take the 1/2 of the middle term. The middle term is negative 2, so you take 1/2 of that. That is negative 1, and you square it and add. So negative 1 squared will be 1 squared. Right? Or if you want to put negative 1, I don't care. Right? Okay, the same thing. Okay, and that's on the left hand side. On the right hand side also you'll have to add it. So we add 1 squared onto the right hand side also. Alright, So now what happens is the left hand side is a square, right? So x squared minus 2x plus 1 plus y squared, the right hand side is just 1. Put the parentheses here. Now this is the square of x minus 1 squared, right? With that, how do you get that? You take the x, you take the minus sign, and you take 1/2 of this one, which is 1, and the complete square of that, plus y squared is equal to 1. And this is an equation of a circle. Now in this form, you can just read off the center. Center's coordinates are 1 here. This is like y minus 0, so the y coordinate will be 0. So the center coordinates are 1 and 0, and the radius of course is 1. So the graph is actually given here. So the graph is a circle with a center at 1, 0, and the radius is of course equal to 1. So basically we started off here and we multiply both sides by r, and we replace r squared by x squared plus y squared, and the 2r cosine theta by x. We got this, and then we brought everything onto the left hand side, completed the square, and then we have an equation in x, y, y, which is an equation of a circle. So the graph of this particular polar equation is a circle. Now as a video exercise, I want you to tell me what this curve r is equal to 4 sine theta will look like. So once again, the best way to do this would be to multiply both sides by r, and then proceed as follows. Only thing, the left hand side will still be the same, but the right hand side will be slightly different. Alright, you need to show full work when you do this problem. Okay, have a great night. See you in the morning.